In this video, you'll see how to calculate the mean, variance, and standard deviation of a discrete random variable. Finding the mean of a discrete random variable is pretty simple. All you have to do is multiply each x value by its corresponding probability and then add those products up. So here's an example. If these x values are 1, 4, and 8 and their associated probabilities are 0.6, 0.3, and 0.1, we just multiply the 1 times the 0.6, we get 0.6. 4 times 0.3 is 1.2. 8 times 0.1 is 0.8. And when we add those up, we get 2.6 for the mean. So it's not very much work. If you have a slightly more complicated scenario like this, it just makes it a little bit tougher, but not too much. You multiply the x values by their probabilities, and then you add up. 2 times 0.15 is 0.3. 5 times 0.25 is 1.25. 10 times 0.35 is 3.50, and then 20 times 0.25 is 5. And when you add them up, you will get 10.05 for your mean. So it's not too bad. The work comes in when you're calculating the variance, which we'll look at next. The variance of a discrete random variable is more complicated. What you have to do is find the deviations from the mean for each x value. So you're going to subtract the mean from each x value, and then you're going to square those deviations. Then you're going to multiply each of the squared deviations by its associated probability, and that's going to give you this formula right here. So you see the deviations from the mean are squared, multiplied by the probabilities, and then all those products are added up. So it's a sum of a whole bunch of products like that. To get the standard deviation, once you have the variance, you just take the square root, and that's not a big deal. Here's an example from before. When we calculated the mean of this random variable x right here, we got that the mean was 2.6. So to find the variance, what we're going to have to do is subtract 2.6 from each of these values. 1 minus 2.6 is negative 1.6. 4 minus 2.6 is 1.4. 8 minus 2.6 is 5.4. And then we're going to square those deviations from the mean, and they're all going to become positive when we do that. Negative 1.6 squared is 2.56. 1.4 squared is 1.96. And 5.4 squared is 29.16. Now that we have the squared deviations from the mean, we're going to multiply those by their associated probabilities and write those products here. 2.56 times 0.6 is 1.536. 1.96 times 0.3 is 0.588. 29.16 times 0.1, just move the decimal point one place, 2.916. Add these up. You get 5.04. The standard deviation is the square root of that variance, and that is approximately 2.245. So it's a little bit of work calculating the variance. We'll look for a technological shortcut after you've figured this out. Here's another example. It's the same example too from before. We found that the mean in this case was 10.05. To find the deviations from the mean, we subtract 10.05 from each of these values, and we'll get negative 8.05, negative 5.05, negative 0.05, and 9.95. When we square these, we're going to get 64.803. 25.503, 0.0025, and 99.003. And then we have to multiply these squared deviations by these probabilities, and we'll get 9.7204 for the first one, 6.3756 for the second one, 0.0009 for the third one, and 24.751 for the fourth one. And when we add these up, we get that our variance is 40.8475. The standard deviation is the square root of that. Square root of 40.8475 6.375 is approximately 6.391. So it takes work, but not too much. You can do this in about 2 minutes maybe, but you really don't want to be doing that too much. Do it a few times to understand the concept, and then use your calculator as much as possible to do this kind of problem. The first thing you have to do if you want to do this on a calculator is put these values into lists. So you go to Stat Edit, and you put the values into the list. So we have 1, 4, and 8 in list 1, 0.6, 0.3, 0.1 in list 2. To calculate the mean and the standard deviation all at once, this is what you do. You quit out of there and you go to Stat Calc 1, and then you put in L1 and L2 after that one variable stats command, and when you press enter, there's your mean, 2.6. Your calculator calls it x bar, but we know it as mu. And then here is your standard deviation from that first example, 2.245 approximately. Okay, so it doesn't take long. For the second example here, we'll just do that together. We'll clear out what we have in the lists already. We'll put 2, 5, 10, and 20 in list 1, and we'll put 0.15, 0.25, 0.35, and 0.25 in list 2, and then we'll quit, and we'll go Stat Calc 1, L1, comma, L2, and there you go. There's your mean, 10.05. Here's your standard deviation, 6.391. If you want the variance, you're going to have to square that, but that's not a big problem. So if you have your calculator out, you can let your calculator do that for you too. But it won't do that automatically. The one variable stats does not give variances. It just gives means and standard deviations. But that's generally what you want, and it's very easy to do on the calculator. Now here are the calculator directions for you to copy down, and use this anytime you want to calculate a mean and a standard deviation for a discrete random variable.